Hi there, welcome back. On today's lesson, we are going to look at continuity equation. A continuity equation can be expressed as density, velocity, and area. Looking at this diagram here, we have fluid entering at different points and also being discharged at different points. We have fluid entering from point A, it passes through point B and separates or cause fork at C and D. If we wanted to calculate area, velocity, or volumetric flow rate, even mass, we can use what we call the continuity equation. What the continuity equation simply tells us is that mass at point A will be equated to mass at point B, and also mass at point A can be the same as mass at C and D. Mass at point B can be represented using this mark here, M with the dot. Mass flow rate can be equated to density, velocity, and area. So mass at point A will be density of the fluid, which is constant because we have one fluid entering and leaving. Velocity, which can be presented either U or V. I prefer to use U because V can be confused with the volume. And also the area. At A, this can be equated to density at B, velocity at B, and the area at B. Notice that our density is constant since we are dealing with the same fluid entering through the pipeline, so we will be left with units of our density can be represented as mass over volume. Our velocity can be represented as meters per second, and the units of our area, it's meters squared. Notice that now we are only left with units of our velocity, which is meters per second, and area, which is meters squared. This can be equated to meter cubed per second, and this is the volumetric flow rate. So here we are left with volumetric flow rate at A, which is equals to volumetric flow rate at B. And that is the continuity equation. Now let's derive more equations. Equation 1, volumetric flow rate at A, velocity at A, and the area at A. Also can say volumetric flow rate at B is equals to the velocity at B and the area at B. We can also repeat the very same thing for both C and D. For equation 2, we just derive A, which is the volumetric flow rate at A, the same as the volumetric flow rate at B. Equation 3, volumetric flow rate at point A is equals to the volumetric flow rate at C plus the volumetric flow rate at D. That will be explained in this format here. An area of a pipeline can be represented in this formula here, pi over 4 diameter squared. I hope that makes sense. Thanks for watching.